So in this video, we're going to look at how to calculate a regression equation in a couple of different ways. In this case, it'll be a simple linear regression equation, but we're going to be able to output a variety of different analyses, and then we will use the same data set in later videos to talk about residual analysis, outliers, and interpretation of the R-squared coefficient. So the coefficient of determination. So let's start with when we create a regression equation, we want to start by making a scatter plot. And so we're going to highlight our data. And again, when we build a scatter plot, generally we want the data to fill out the graph. So I'm going to adjust my axes a little bit. I don't see any data. There's one value, it looks like less than 20. So we'll maybe make this 15 to clear out some of that white space. And then same thing, if I double click on the y-axis, the minimum value looks like it's less than 40, but not as small as 30. So we'll clear out some of that. That looks a little better. And so now I'm going to add some axis titles because we want to have a nice graph. This is our age, and this is amount. And I assume it's in dollars. Okay, so we have a nice graph. Now, there's a couple different ways that we can calculate information about the graph. So for instance, we could calculate the slope of our trend line by using a formula in Excel, slope. And we would input the known y values and the known x values in that order, and then enter. We can also calculate the intercept pretty much the same way. There's an intercept function, and then known y's and then known x's. So what this would amount to would be an equation y equals 1.38x plus 11.8. And then we can calculate the correlation using the correl function to see how good it is. And for the correlation function, we don't have to specify, there's not a particular order we have to put things in, which is good. This is a very high correlation. And we can also calculate the R-squared value. The R-squared value is the coefficient of determination, but there is actually a specific function for that, RSQ, R-squared. And this works like the slope and the intercept, the known y's and the known x's. I don't really think it matters, but this is going to be the same value that you would get from taking the correlation and squaring it. Because for a linear regression equation, that's all that is. Now, there's other ways that we can get this information. Another way that we can get the same information is out of the graph itself. If we add a trend line and then go into the More Options button, we can display the equation on the chart and display the R-squared values down here at the bottom. Now, if it turned out that our trend was not linear, then we could use one of these other options to try to get a better fit for our data. But this data clearly appears to be in a straight line. And so we're going to stick with our linear equation. Notice, though, that when we pulled the equation off of the graph, we basically got the same values. They've been rounded to 4 decimal places in this case, 3 decimal places here, 4 decimal places there, a certain number of significant digits. But they do match. Our R squared is the same if we rounded this, and our slope and our intercept are the same that we got here, again, rounded to the indicated number of decimal places. So that is another way that we can get our trend line and our correlation values. We could get the correlation from the R squared value in our graph by taking the square root. The correlation square root of the R squared value. We will get the correlation back again. If you take it off of this graph, there may be some errors in the decimal places beyond 4 digits because it's already been pre-rounded for us, but it will otherwise be the same value. The only thing you have to watch out for doing it that way is that the slope of the line, if it's positive, you'll take the positive square root. And if it's negative, going this way, you would need to take the negative square root for that correlation. So it would be the negative version of this. Now, the other way to get all of this information is, of course, to then use the data analysis tool pack. And the data analysis tool pack will give you lots of information. So data analysis. Now we're going to look for our regression function, which is down here. And input Y. This works like the functions in that it wants Y first. And I should mention, you can't actually use the columns like that. It doesn't like that. You have to actually highlight the exact values. And then the X range. I highlighted the labels, so I'm going to check the labels box. If you do not highlight the labels, don't check this box. So I highlighted customer age. I started at B1 and A1. So I checked the labels. If you start at line 2 and then you check the labels box, these first numbers will be counted as labels and they won't be included in the calculation and it will not work properly. And I'm going to put this out here just on the edge of my graph. I'm not going to worry about these right now because we're going to talk about these in a future video. And again, this statistical output, most of this you do not necessarily need just to find the equation. They will be useful in more advanced analysis, but here are our coefficients. And I'm just going to highlight them because these are the same values we got from our graph, which were the same values we got from our slope and intercept functions. And here are our correlation and our R squared values, which we calculated earlier from the graph and from our correlation and R squared functions. So these tell us the same kind of information that we calculated individually. In addition to that, this also gives us information for particularly about things like if we're doing hypothesis testing, then the model hypothesis test is based on this significant score right here. This is the p-value essentially for the whole model test, and it will match the p-value for the slope coefficient, because essentially we're thinking about the relationship between one or more of the variables, and there's only one variable in the problem, so these will be identical when there's only one input variable. You may also wonder if you should set your intercept to 0. Some cases, for instance, we may look at this problem and think, maybe we do want to set it to 0. This p-value will tell you if it's too high, if it's above 0.05, that you should eliminate the coefficient, set that equal to 0, That is also a setting on the graph. Set intercept to 0. You can set it to anything you want in particular, but particularly if you set it to 0, that will simplify your equation considerably. But don't do that unless your p-value here is particularly high. And I'll just check it and then uncheck it so you can see what happens. If I check it, notice that my equation changed, and so did my r-squared value. But I don't necessarily want it to be 0. Typically, for something like housing prices, if you're getting your house appraised and then you're selling it, it would be reasonable to think that if it was appraised at $0, you would be able to sell it for $0 and not something more or less than that. And so that might be reasonable to set the intercept equal to 0. There are certainly cases where you don't want to intercept. But in this particular case, the p-value is definitely small enough that we would want to retain the intercept. So this is an overview of how to do regression in Excel. And what we're going to do next in the next couple of videos is we're going to talk about residuals, and we're going to talk about outliers.